Hi everyone, my name is Megan Bales. I am a graduate research assistant in the Human Factors and Aging Laboratory in the College of Applied Health Sciences, and this is my stretch pitch competition slideshow. Alright, so as we all know, the older adult population does continue to grow, and with this, there's an increase on demands for the healthcare system. 1 in 4 older adults report having a mobility impairment or mobility limitation, and this can increase the fall risk. In 2030, approximately 12 million injuries will be caused by falls, accounting for almost $100 billion in healthcare costs. Falls can occur due to extending past the safe reach distance due to mobility limitations. This could include things like grabbing something off of the floor that they dropped or reaching for something high on a shelf. This limitation can inhibit abilities to complete everyday living tasks and, in turn, someone's ability to live independently. The stretch robot does have extensive potential to help with everyday living tasks. Feasibility testing exposed some barriers to grabbing handles of different widths and shapes. So there are a few solutions here. We can make handles for each device or each handle. However, this demands the care partner to adjust products for each tool. It could also be cost ineffective, meaning they have to buy too many different devices to attach, or it might not be feasible for the end user to do this themselves. We could also create different grippers to better manipulate specific objects on stretch itself. However, this could be costly. So I actually got inspired for this idea back in Florida when I was scuba diving and was wondering how sea creatures have this ability to pick up different objects and move them without hands. So things like starfish or sea cucumbers. And I was perplexed, and I thought, we don't need to make a gripper more usable. Maybe we just need to make the utensils being gripped grippable. So how could we do that? How could we utilize the same concept of how sea creatures are gripping objects? And I thought, well, using this organic, malleable concept to design a tool that can be attached to any handle to improve grip for the robot without having to buy multiple sizes or spending money on new end effectors. So this is where I got the idea for a universal handle and started brainstorming different ways to form an outer shell as well as some infill to be able to design a either a slide-on or a clip-on handle that can be put on anything around the home that may be different shapes, so that stretch has an easier time grabbing anything because the handles will all be the same. So the first iteration of the universal handle shell will be 2 inches long, 3 inches wide, and a diameter of 0.3 inch thickness. I'll print this first iteration at a 10% infill of PLA material. I'll test this prototype in the McKechnie family life home, and the inside of the shell could consist of 2 different fillings. So the first infill that we decided to look at was nylon netting. We chose the nylon netting as an option as it's cheap and malleable. We chose the width of the shell to be 2.5 inches as the hair ties that these are easily acquired by are about 3 inches wide. So the smaller shell will cause more tension where the handle of the object will be placed, allowing it to manipulate some heavier objects. So for example, if you're using a spatula to flip a pancake. We also have this idea of a silicone-based concept. However, we will have to do some more research to figure out what's out there. We like this concept because it is a little bit more rigid than the nylon netting option. However, finding tubing that can malleate to different handles and then return back to normal has been a little bit more difficult. So finally, our design method and approach, we will do some materials testing to test the size and the infill, as well as feasibility for the ability to put this on different handles, such as a toothbrush, a scratcher, a razor, or even a plunger. We'll then be able to test the efficacy of using the product to complete needed tasks, which we'll do this by a task analysis, and then also do a comparative analysis to see what benefits this could provide over things that are already out there. We do need to do this within the life home because we'll need to utilize stretch to see how the gripper works with the universal handle. We'll also be needing to test tools within the environment, like a scrubber and a sink. It will also be nice to be doing this in an ADA compliant house, so we have a nice standard that we're starting off by before introducing environmental barriers. So that concludes our pitch presentation. Thank you all for taking the time to listen.